Already marked. Our two congruent sides are segment AB and segment AC in this triangle. And you can see that because they are marked with those lines that we've been doing all along. Okay? By definition, an isosceles triangle has two equal sides. That's what it means to be isosceles. Okay? Now, your vertex angle is where those sides meet. Okay? Where those equal sides meet, that's your vertex angle. The vertex angle in this triangle is angle A. Now, that's not to say that it's always angle A. But remember, the vertex angle is where the equal sides meet. The vertex angle is where the equal sides meet. In this case, it's A. Notice how it's labeled now, angle A. The other two angles that aren't vertex angles are known as the base angles. All right? They make up the base of the triangle. So if I can switch back to blue, the base angles are angle B and angle C. Those are the base angles. Please notice how I labeled the base angles, B and C, with red. Base angles. So again, the vertex angle is where the equal sides meet. And the other two angles are the base angles, labeled here, angles B and angle C. The base of an isosceles triangle, there's a lot of different ways of looking at it. Okay? The base is a segment. It's the segment that is included by the two base angles. That's one way of looking at it. Or you could just say, hey, it's the side that's not one of the two equal sides. Or you could say that the base is the side that is opposite, that is across the triangle from the vertex angle. So there's lots of different ways to look at the base, but the base in this case is segment BC. How this works, okay?
Is that really dumb, boys?
I'm recording right now.
Oh.
Okay, so the isosceles triangle base angle theorem says, whoops, I need that. If I have a triangle, it says if two sides of a triangle are congruent. So your given is that in this triangle, I have two congruent sides. That makes it isosceles. What you can conclude is that the base angles, or the angles opposite them, are also congruent. So you'll come along and you'll say, hey, based on those two sides being congruent, we know that this angle and this angle are also congruent. Your picture of this one, again, now you're given is that you have two congruent angles. Okay, so you walk up to this triangle and the triangle says to you, hey, I have two congruent angles. I have two angles that are the same. You can say to that triangle, ladies and gentlemen, hey, by the converse theorem, I know that the sides that are opposite of your two angles are congruent. Okay? So, I guess this picture, the first picture really is meaningless. But do you see how they're just converses of each other? The first one, the Itbat theorem said, hey, I've got two equal sides. And you said, oh, well, if you have two equal sides, then you have equal opposite angles. That's the Itbat. Itbat converse, you come up to it and it says, hey, I have two equal angles, and then you could conclude that the sides opposite them are congruent. So they just say the same thing, only they start in opposite ways. Okay? Just quite simply, hey, given, I have a triangle. It has three equal sides. So we would mark those with three equal markings. By this theorem, it says, well, if you have three equal sides, then you also have three equal angles. Again, equilateral means three equal sides. If you have three equal sides, then you have three equal angles. And the equal angular theorem says, hey, you have three equal angles. You can conclude you also have three equal sides.